Hello, myself Naveen. In the course Wireless and Mobile Communication, code KEC 076, today we are going to discuss about the introduction of mobile ad hoc network. In short, we call it the Manet. So what actually Manet is? So in the diagram, even you can see that there are different mobile phones which are scattered in the mobile fashion and they are not fixed at one place. So it means the meaning of that is the term ad hoc. It is temporary or when needed. So this is infrastructure-less architecture, and in that meaning shows that the ad hoc means the mobile phone or sensors, whatever the devices are there, they are deployed in a irregular fashion. So it shows that it means the network that is temporary or set up immediately when needed for the random temporary access. So no architecture is there, randomness is there, and they form the network as per their requirement when they are in mobile in nature. So ad hoc network is a group of locally available devices that can connect and talk to each other directly whenever needed without the need of any router or the server. Okay, so all the devices can communicate with each other which is into their range, and there is no fixed server for controlling these devices. There is no router is there through which any device can be act as a router as well, but there is no specific router, right? So source and destination which we have to define, and accordingly in between different nodes are coming into that, then that will be act as the different hops or the routers. But there is no fixed routers are there. So there are some of the features of Manet system. Into that, there is no hardware or fixed infrastructure, and the mobile devices which are involved for talk or transferring the data directly to each other autonomously or automatically as well. Second feature of the Manet is the self-repairing. So means if any device is somehow it is faulty, so in that case automatically it will debug its own system and it will be into the action mode. Auto configure, as I said, the meaning of the Manet, that is it is not configuration which is defined, so automatically it will configure its own network to make it for data transmission or for the talk or the call. Second, then it also known as the wireless ad hoc network and also called the WANet. Okay, so WANet, on the fly network or the spontaneous network. So these are the different names which are given to the Manet. Next is, in each device itself acts as the router and it transfers the data packets to the other device mobiles. So any device can be act as the router into the system, or any device can be act as the server into the system. So in that way any device can communicate with the another device, as we said, if in between there are different nodes are there, so those nodes can be act as the intermediate nodes, okay, between the source and the destination. So how it works in the system? So it works as an individual exclusively or in the group as a part of a huge network like the internet. So internet hub is there. So all devices can communicate with each other in a group or in a different networks as well. And there is no access points or there is no hardware is there which is controlling the different devices. Next is the direct and the autonomous communication is there between the mobile devices. Next is devices search each other themselves and communicating with start communication. So as we said in the Manet, source and destination is defined only, but in between if any device wants to communicate with the another device, so automatically one device will be act as a source and the second device will be act as the receiver. In the vice versa, if in any other time instant the same device which was source, it can be act as a receiver, and the device which was a destination, it can be act as the transmitter as well. Okay, so if a node is far away, then the nodes between the source and destination, it act as the router. And transfers the data one by one, which makes it easy to destination node. Okay, so this is the basic definition of the Manet. Then these devices, it can join or leave the network anytime to the dynamic node, and addition or removal happens also. So in that way, if in any network any device is got faulty, so automatically that device will be act as a dump, and it will not be used as a service node, right? There is no action will takes place onto that node, and automatically it will be out of the system or the network. Then the devices which have their own backups of the energy, like the batteries and for the power. So just like the sensors, so if you deploy the different sensors into the network, so each sensor will have the different batteries, and they will automatically charge and reconfigure itself in the Manet system. So some of the applications of mobile ad hoc network is there. First application is the gaming service. So in the gaming service, for collaborative gaming in the local area network, in the schools or competitive competitions, etc. So just like if you are here the Counter-Strike as well. Okay, so different systems are connected with each other. There is no server for that particular system. So this type of gaming culture occur when we use the ad hoc networks. So these networks are ad hoc, and automatically if any of the system is shut down, so that system will be out of that network, and rest of the system can be used for the playing the games. Next application is the military services. So for that, immediately sending the information to all the remote troops or battalions for meetings or any of the message, if anyone wants to transmit or broadcast from for transmit end to end or one point to one point, this transmission can also occur into that. Then for the commercial use, local conferences or the seminars, that can be used here. Then commercial sectors, also the one area into which the Manet system will work. Emergency services like the earthquakes, disaster relief, firefighting, natural disasters, and basically which needs services without the infrastructure, right? So where there is no infrastructure is required, so this type of applications can be used in the different domains. Then education sector, into that in the classrooms as well, laboratories of the school, colleges, etc. for sharing the lectures. Okay, so there are different different applications are there for the Manet system. Then Bluetooth communication is also one of the communication domain into which the Manet system works. So simply if you want to transfer the one file to another mobile phone, just for example, so when we use a Bluetooth system, so the Bluetooth system is what? It simply select the device to which it will transmit the text or the any type of data, video or audio kind of things, right? So in that way, these Bluetooth devices can be act as the Manet system. So there are some of the characteristics which are there for the mobile ad hoc networks. So for that, first one is the no centralization control is required. So the working is completely dependent on the behavior and support of the participating devices. So in the network, if the 10 devices are there into the system, so these all 10 devices can be connect each other or configure each other or reconfigure each other as per their requirement. So there is no central controlling unit is there for controlling all the 10 devices, right? Then we have random change of devices. So devices keep on coming and leaving the network at a huge pace or the voluntarily as per the requirement. Just I give the example of any of the faulty device, so that can be removed from the system automatically, or if it has the capability to reconfigure itself, maybe of the any kind of fault is there, if it can recover itself, then it can be used automatically. Okay, so as per the requirement, these devices can come in and leave the network. Frequent changes in the network topologies and the arrangement of devices in the network. So as the devices will come and go or leave the network, so as per the requirement, the different topologies are also there, which can be used for transmitting for sending the data from source to destination. So as per the requirement, these devices can be act as the source, or any other device can be act as the destination, and intermediate devices can be act as a router, maybe act as a relays, and maybe some of the server as well. But it is within the system. There is no specific thing is there. Any device can be a router, relay, or the server at any time. So the same another device can be the relay, router, and server at another instant of time, right? So it will not be fixed. Okay. Then as I'm simply talking about the sensors, so sensors are it requires a very less battery. So limited battery backup, limited battery power is required for this type of the networks. Limited human interventions or the interferences also there, because these devices can reconfigure itself, so there is no need to check the fault by the human to remove that and then place into the network. So that device is not useful in that case. So another device can act or perform in their task. Less security. So these networks have the bigger threat or on the wire than on the wire network, because we don't know which device is transmitting, which devices act as the relays or the routers between that. So this will be changed as the time passes. Okay, so but the issue is there because everything is on automatic mode. So in that case, the security will be less, right? So in that way, security is one of the main factor into the managed system, but it is very much desirable, which can be useful in upcoming days. And just like the IoT, one of the example for that one is also there. Internet of Things, in which the managed system is also used. So the devices that involved in the networks being on so smaller nowadays, it can be easily be a victim of the theft. So these, just like if you deploy the sensors or any of the devices into for creating the network, so these are random deployment, right? Random deployment of the system. So obviously when there is a random deployment, there is no we are not making any controlling unit for controlling all the devices. So it means the security is less in that case. Anyone can theft the information from the devices, but still it is very much useful, because in some way because others don't know which one is source and destination, or how many relays are there, how many hops are there between the source and the destination. Some benefits are there, but some of the issues is also involved into the managed system. This was the case when we had the very previous managed systems, but now it is a very advanced where the security is also introduced into that in a very efficient manner, right? Okay, then some of the characteristics also there again. They can be attacked easily. Each device acts as the router as well as head of the network, and so each device plays the twofold or the double roles as per the requirement. Limited bandwidth. Okay, so these networks have the very little capacity or the range of the data transmission for source to the destination. So limited bandwidth is one of the constraint into the managed system. Low resources such as the memory power, battery power, and the backups, right? So these are the also the constraints or the less applications in which low power battery devices are used. In that case, this managed system is very useful. But when the applications are like that, where we require a very large battery or very large battery backup, so somehow some limitations are also involved into that. Performance is high with low expense, and the scalability advantage is also there. Another feature of the mobile ad hoc networks. Okay, so here this is comparison between the cellular network, which we have discussed in the previous lectures, and the ad hoc network. So what are the basic comparison between these two? So in the cellular system, we know that the network routing of the cellular network are centralized. Okay, and all the traffic goes through the base station, right? All the mobile phones are connected with the base stations. So if one mobile wants to communicate with the another mobile, so it means that call or the text messages, this will go by connection will make by the different BTS, right? Base stations or the BTS systems. But in the case of the ad hoc network, the network routing of ad hoc network are distributed in nature, and there is no centralized system is there, such as the base station where the needed in the cellular system. So here these are very less expenses are there because there is no centralized unit. So there is no cost of the base stations. There is no complexity which is controlling the devices. But in a cellular system, we also require one central unit. That kind of BTS is there, base stations is there, which will coordinate the mobile stations. But this type of things are not in the ad hoc network. So this is a basic difference. If the mobile phones can communicate with each other without using the any central unit, so in that case, those mobile phones can be the part of the ad hoc network. Okay, so second is in the cellular system, circuit switching are used. Most probably circuit switching are used, but in the ad hoc networks only the packet switchings are used. Cellular system, single hop type is there, and it has the multiple hop type system is there. In the cellular system, star topology are used, but in the case of the ad hoc network, the mesh topology are used. These are basic differences or the comparisons between the cellular and the ad hoc networks. Fifth one, it takes higher cost and takes more time for the deployment. But in the case of the ad hoc network, it takes lower cost, doesn't take more time for the deployment because there is no cost of deployment of the base stations. Sixth, it is used in the designed and developed for the voice traffic. In the case of the ad hoc network, it is used in the design to meet best effort to data traffic requirements for transmission from source to destination. Here, low call drops during the mobility due to the seamless connectivity across the region is there. In the ad hoc network, there's high breaks in the path during the mobility when all the nodes are moving in nature. So in that case, the seamless connectivity is very less, right? So in that case, due to the mobility, if these are fixed, there is less culprits are there. But if there is a mobility is there, in that case, the seamless connection is very tough to maintain. Then it requires periodic maintenance, so it is costly. Here nodes are self-organized. This is the very important feature of the ad hoc network. Thus, these self-organizing nodes are there. The allocation bandwidth is guaranteed and easy, and the allocation of the bandwidth is based on the shared channel using the complex MEC algorithms. Examples of the cellular networks, that is IS-95, 136, GSM, mobile WiMAX, CDMA, LTE technologies which are used, and even 5G networks are also there. And the WLAN 802.11e technologies are used in the case of the cell ad hoc networks. Then frequency spectrum is reused through the geographical channels, and dynamic frequency are used through the carrier sense mechanism. Okay, so these are the comparison between the cellular network and the ad hoc network. This is very, very important, and most of the time in exam they ask this type of questions. So as we graphical representation, we can see here that they have formed the wireless hosts which may be mobile, or no pre-existing infrastructure is there. Routers between the nodes potentially contain multiple hops. So nodes act as the routers to forward the packets for each other, and nodes mobility may cause the routers change. So here we see that from A, C and D, E, every node like A has this type of coverage. Node B, it has this type of coverage, and similarly the node C has this type of coverage, and so on. D has this type of coverage. So if you're using the omnidirectional antennas for all the ABC nodes, so it has the its own coverage area. So if okay, so here we see how the path can be checked. So which is the nearest path, so how it will follow. So this path can be when at one instant of time, this was the path from we are moving from A to B, B to C, C to D, right? Or it can be the possibility of A to C, C to D. So there are two possibilities for reaching from the node A to the node B, D. When after some instant of time, so these nodes are moving, and this B nodes is like that. This is moving and it is reaching to this point. So in that case, the path from A to D is a source, and we can say this is source and this is the destination. So in that case, the path will follow like this. Okay. So main constraint for important point is into the Manet system is the searching the path. So different algorithms are there for searching the path from source to destination. It may be that some nodes are introduced into that, or some nodes are used as a router relays as well, right? Or sometimes the source and destination there is no relays, so direct path is there between source to destination. Okay, so now come to the routing protocols. What are different routing protocols are there? This simply overview. Some example we can see, but this complete classification we must know about the routing protocols. So this routing protocols is nothing but for searching the path from source to destination. That's it. So this is divided into three parts. Manet routing protocol. First one is the proactive routing protocol, reactive routing protocol, and the hybrid routing protocol. Proactive routing protocol can be of two types: DSDV routing protocol and the GSR routing protocol. Then we have reactive routing protocol, into which DSR is one kind of routing protocol and the AODV is another kind of routing protocol. Third classification of the Manet routing protocol is hybrid. So the example for hybrid routing protocol is the ZRF, that is the zone routing protocol. So it was this is a hybrid of between this hybrid or the combined effect of the proactive and the reactive routing protocols. So in the proactive routing protocol, what is that? These are known as the table driven routing protocols. Each mobile node maintains a separate routing table which contains the information of the routers to all the possible destination mobile nodes, right? Since the topology in the mobile ad hoc network is dynamic, so these routing tables are updated periodically, as well as when the network topology is changing. So this what is that routing table? So this routing table contains the information about the source and destination plus the routers between the source and destination. So this information will be updated periodically. It has the limitations that it doesn't work well for the large network as the entries in the routing table becomes too large, right? So there are some of the limitations is also there, which need to maintain all the time, and we have to give the updates all the time in the proactive routing protocol. Into that, destination sequence distance vector routing protocol, DSDV. So it is a proactive table driven routing protocols. It actually extends the distance vector routing protocols of the wired network, such as the name suggests, obviously, and it is based on the Bellman-Ford routing algorithms. Then distance vector routing protocol was not suited for the mobile ad hoc networks due to count to infinity problem. So this is one kind of problem is there into the this protocol. So the solution for destination sequence distance vector routing protocol came into the picture, right? So how it works. So destination sequence number is added into that. This is the solution for that. What we do, so when we have the source packet, so when we transmit the source packet, so we add on the sequence number, destination sequence number, with every routing entry in the routing table, which is maintained, right? So by each node, and a node will not include the new update in the table only. If the any entry consists of the new updates, route to the destination with the higher sequence number. Then we have the global state routing protocol, that is GSR. It is again the proactive table driven routing protocol. It actually extends the link state routing of the wired networks, and it is based on the Dijastra's routing protocol. Link state routing protocol was not suited for the mobile ad hoc networks because in it each node floods the link state routing information. So this link state routing information is also flooded along with the information into the whole network. Okay, so that is the global flooding, which may lead to the congestion of the control packets in the network. So as a solution, this global state routing protocol is there. So into that routing protocol, which does not flood the link state routing packets globally into the network. So in GSR, what happens? Each of the mobile node maintains one list and three tables, namely the adjacency, list, topology table, next hop table, and the distance table. So this type of table is introduced into the GSR, which is not the general case of the link state routing protocols. So which was the Dijastra's Dijastra's routing algorithms. Okay. Then reactive routing protocol. So these are known as on-demand routing protocols. So in the on-demand routing protocols, it is type of routing. The route that is discovered only when it is required and needed. But in the case of the proactive routing protocol, every information has to be added into the when it transmits through the transmitter or from the source. But in the reactive routing protocol, this is on-demand routing protocol, into which, as per the requirement, the this information will be added on or removed from the system. So the process of route discovery occurs by flooding the route request packets throughout the mobile network. It consists of two major phases, namely the route discovery and the route maintenance. So these two major issues or the phase are there into the reactive routing protocols. So in that, we have the example of the dynamic source routing protocol, which is reactive, or the on-demand routing protocol. And in this type of routing, the route is discovered only when it is required or the needed. So okay, so that the process of route discovery occurs by flooding the route requests packets throughout the mobile network, and it consists of the two phases. First one is the route discovery. First it will discover the route, then it will maintain the route also. So this phase determines the most optimal path for the transmission of the data packets between the source and the destination mobile nodes. And the route maintenance This phase performs the maintenance of the route as the topology in the mobile ad hoc network is changes, because it is dynamic in nature. So maintaining the route is very, very important. So in all the topologies, but in the route, in this DSR, dynamic routing source routing protocol, so in that the maintenance is also introduced. Ad hoc on demand vector routing protocol. So into that, it is a reactive on demand routing protocol. It is an extension of the dynamic routing protocols, and it helps to remove the disadvantage of the dynamic source routing protocol in DSR. So what happened into that? In the DSR route discovery, when the source sends the data packets to destination node, it also contains the complete path in its header. Hence the network size increase and the length of the complete path also increased, and data packets header size also increased, which makes the whole network slow. But in the case of ad hoc on demand vector routing protocol, it came as a solution of the DSR, which makes the main differences lies in the way of storing the path. So AODV stores the path in the routing table, whereas the DSR stores it in the data packets. Okay, so this is very big difference into the AODV. So this information, how it will be stored into the routing table, right? So these differences are very, very important to come to know. And then finally we have the hybrid routing protocol. So it is basically the combined advantages of the reactive and the proactive routing protocols. So these protocols are adaptive in nature and adapts according to the zone and position of the source and destination mobile nodes. So one of the example for the hybrid routing protocol, that is the ZRP, that is the zone routing protocol. So into that, the whole network is divided into the different zones, and then the positions of the source and the destination mobile nodes is observed from the observed, and if the source and destination mobile nodes are present in the same zone, then the proactive routing is used for the transmission of the data packets between them. And if the source and destinations mobile nodes are present in the different zones, then the reactive routing protocol is used for transmission of data from source to destination. So this is a basic difference between the when we use a zone routing protocol. Okay. Oh, fine. Then there's some of the trade-offs are there, like latency of route discovery and overhead latency of the route discovery. So proactive protocols may have low latency since routes are maintained at all times, and reactive protocols may have the higher latency because the route from the X to Y may be found only when the X attempts to send to Y. So overhead of route discovery and maintenance. Reactive protocols may have lower overheads since routes are determined only if needed. In the proactive routing protocol, it can, but not necessarily, results in higher overhead due to the continuous updating of the routing table. So which approach achieves the better trade-off depends on the traffic and the mobility pattern of the different nodes into the system. This is an example of dynamic source routing. So where what it says, first one, source S wants to send a packet to node D but doesn't know the route to D. Then node S initiates a routing process, runs in the three phase: route discovery, route reply, path establishment. And second one is the route discovery. So in that, the source node S floods the route request. Each node appends on identifier when the forwarding the request. Okay, so every source will from source to destination, the source will append the other informations. So it represents a node that has received a request from the D for D from S. So this is a source, this one is a destination. So in that case, what will happen? This source will send the information by the nearby into its coverage. into this coverage to the different nodes. So this B, C and E will have this information. For the root discovery is there S, then each E, C and B, this will also transmit its own data. So source header will be connected with the E and the S, so this will transmit in that way. And this also, I mean, all the nodes will transmit the data information of the root discovery request to all the nodes. Okay, so B will send to S, S will send to B, and B will send to C and H, which will come into its own area or region. So S and E, then S and C, these are the two information. Then in that case, this from the, you can see from F and G. So from that, this information is S, the path is there, S, E, F and then J, and for this case S, C, G and K. So one path is here and second path is like this. So similarly again it will distribute here, this will distribute here, and like from there. So we can see that this is our destination path. So obviously which one is the nearest one? So there are two paths are there. First one is this one, second one is this one. So it will choose one of the path from here, which requires less nodes for transmission of the data from source to destinations. So in that way, this is nothing but this is simply a representation. So through which the data root discovery is occurred for the transmission of the data before transmitting. Then the root reply. So the destination D, on the receiving the first request, sends a root reply. Okay, so root reply is sent on the root obtained, reversing the root appended to the receiver REQ. Then RREP includes the route from source to destination on which the RREP was received by the node D. So we can see it here. Now we found this one. So this guy is choosing this path. So this will send the root reply from this path, okay, in the opposite direction. So after that the root will be discovered. Okay, then root reply in the DSR, node S on the receiving reply catches the root included in the RREP, where node S sends a data packet to D. The entire route is included in the packet header and the name source routing is there. Then the intermediate nodes use the source route included in the packet to determine to whom a packet should be forwarded. Okay, so let's see. Third one is final stage is for data transmission from source to the destination. After searching the path and then reply from the D, and as this is the reply that the route is like this, then after that the source will transmit the data or data packets to the D via this route. Okay, so this is the route request, route discovery, and the maintenance also there. Next is the location added routing, last one. So into that these are one kind of routing things where it exploits the location information to limit the scope of the route request flood. Location information may be obtained using the GPS, and expected zone is determined as the region that is expected to hold the current location of the destination, and into that the expected region determined based on the potentially old location information and the knowledge of the destination speeds. So into that route request limits to the request zone that contains the expected zone, that is location of the sender node, and then finally finding the destination zone node into the node. So in that way, this location added routing is also one of the method for the transmitting the data from source to destination. So power aware routing is also one of the modification to DSR. It's also there where the power routing for no routing catching, no routing is there. I mean, no power concept is given in the previous cases, but this is a modification in the DSR. So power concept was not there. So into that route request aggregate the weights of all the transverse links, and destination respond with the route reply to the route request. Okay, so it provides the weights, means which link is better or which link is worst. So it choose by the based on the power linkage, right, between the one node to another node. Okay, so I think I have cleared all the Manet system. So these are the references which I gone through. So thank you very much.